Hey guys, welcome to the Introduction to Data Science series. And this is session 7 where we will be talking about A/B testing. तो हम अ और ब के टेस्ट के बारे में बात करेंगे. Actually, this is what we call it in Hindi, right? A B test. Anyways, jokes apart. A/B testing is a very important area in product analytics in a lot of e-commerce companies and other technology companies around the world. Right? It is one of the forefronts of applied data science, but it is generally not categorized in data science. It comes under the purview of product analytics. But nevertheless, a lot of data goes into analyzing the different kinds of experiments that need to be performed. A lot of statistics goes behind it to understand what kinds of features should be enabled on web pages for customers to like them, right? Do you like a red button? Do you like a blue button? So this is very simple example, but whether I should have a call to action button on the top, like schedule a call with me now or with our business now, or should I have it in the bottom for it to be attractive to you? So a lot of these decisions, right, for the user experience are made through A/B testing. And companies like Airbnb, Facebook, Amazon, Google, they are running thousands of experiments with millions of users at a point of time. And for different purposes, right? For their search, for advertisements, for recommendations, personalizations, and so on. So A/B testing is widespread and you should definitely care about it. Now let's talk about a little bit in detail what is A/B testing all about. As the term suggests, we are looking at two versions of a particular item, right? Or a particular web page of any particular decision that we want to make. So we have two versions, A and B, right? So A/B testing deals with two versions primarily. That's what we are looking at here. We are looking at a web page which has a certain format and a layout, and we are looking at another web page, version B, which has another layout, right? It is different from version A. And the question here is, which of these should we deploy in a particular website or in our business so that our engagement metrics or people are more people are landing to our page and they are getting converted more, they are getting engaged more, so they are spending more time on our page. So how do we ensure that these metrics are improved so that finally our revenue is improved, right? So that is the context behind it. To run an A/B test, we know that we have a set of customers which are coming in into our business, right? What we want to ensure to understand which of these versions is better is we want to ensure that one set of customers will be shown version A and another set of customers will be shown version B, and depending on their conversion we will say which one is better. But for doing so we need to make sure that the customers which are coming in are very equally distributed in the two groups, right? So there's no difference between how they are distributed in their age, gender, preferences, and so on. So they have to be randomly distributed, and we take two subsets of from that population of incoming customers. We divide them, right, randomly at the same point in time, right, to these two versions, version A and version B. And then we measure how much is our final metric, right? So for example, if we are talking about a conversion rate, this is 25% for version A, this is 75% for version B. So we can make the conclusion that version B is better, right? So after this point, comparing version A and version B, it comes under the purview of statistics where we are making the hypothesis that we are making three hypotheses. Version A is not different than version B, right? Version A's conversion is better than version B's conversion, or version A's conversion is not better than version B's conversion. So this becomes a two-tailed hypothesis test, right? Before this, what we care about is the experimental design. How are we designing our experiment? So what kinds of customers are coming into our website and how are we dividing them? How are we randomly distributing them? So we cannot, for example, if we have customers coming in every day, we cannot make a subset that on Monday, Tuesday, Wednesday, version A will be shown on our website, and on say Thursday, Friday, Saturday, Sunday, version B will be shown. Why is that the case? Because there's a temporal difference. The types of customers that are coming in on Monday, Tuesday, Wednesday might be different from those that are coming in on Thursday, Friday, Saturday, and Sunday. So we want to make sure that the distribution that we are feeding into these two versions is very identical. So it is completely randomly distributed and it follows the same distribution as the original, the entire population. So for that, we need to ensure random distribution. And this is one of the principal experimental design that we need to think about. We'll talk about this more in detail very shortly. Now, let's come and understand the key terminology of experiments. We talk about a response variable, which which can be thought of as the metric that we are interested in. So it can be a conversion rate, right? The customer is coming onto a page and we want to sell a product to him or her. How likely is he to click on that button which directs him to the next page where he can make the checkout? So that is a conversion for that particular button, right? There we can measure the conversion rate. The time on the page measures engagement. How much time is a particular user spending on our page, on our web page, right? Is he scrolling down completely, or is he just spending 2 seconds just glancing through it and just moving away? So what is the total time spent on the page? And that measures engagement. Then we have the revenue per visitor. So this can be thought of as the complete revenue per visitor. The entire action, all the actions that he takes through the funnel, once he lands on the page, once he clicks certain buttons and he navigates the material, right? So you get ad revenue, you get final conversion revenue when he actually buys the product, and so on. So it is the total revenue per visitor that can also be a conversion to see the amount that we are spending, right? And the design decisions that we have made, do they convert to revenue or not? And finally, you have the bounce rate. How many people are coming in and just leaving? They're not doing anything on our business page, right? So these are the response variables, which can be some factors which you want to improve. And that's why we want to measure these and improve these. Then come the explanatory variables, that are the decision variables in our hands, also known as factors, that we want to basically control and optimize. These are the variables that affect the response variable. For example, the conversion rate is tied to a particular button, right? And if we are putting that button completely at the top, a person who's directly coming in and he's interested in what the page looks like, he can directly click that button and go to the next page. But another person who's coming in and he is interested in the content, but he's not able to find the button. It's very small and it's stuck somewhere, in the corner. He might not be able to find it and not be able to click it. So the conversion rate might be slow for that particular position and size of the button, right? So this isn't factor. Here the factor is the button's location, right? And it affects the conversion rate. This is called the explanatory variable. We then have experimental conditions, right? So an experimental condition is basically defined as the combination of levels of one or more factors. Like we talked about the button's location, the button is at the top and it's huge, or it is somewhere in the corner and it's very small. These two particular alternatives each correspond to a level of the factor being the button's location and the level being whether it is at the top and large or whether it is at the corner and small. So a combination of different levels, right? So one factor can have only one level mostly, right? So button's position will be here. Say we also want the button's color, that is another factor, right? It can have another level, red, green, blue, or something more professional for a business page. So a combination of these two particular factors, the location as well as the color, the combination of such levels of different factors, more than one factor, is an experimental condition, which we are basically testing when we are talking about versions. So version A can have multiple levels of different factors, right? That means with each factor, we will have one level and there will be multiple factors which are involved in version A, say like the location of the button, the size of the text and so on. And version B will have a different set of levels for the different factors. And then finally, we come to experimental units, which what I've denoted here as the people or the users which are coming in. These are the experimental units which we want to assign to these experimental conditions. So the experimental conditions are version A and version B, and the experimental units are flowing into these different versions, and then we are measuring the particular response variable that we are interested in, calculating the metric, and then finally saying, based on our statistical hypothesis test, which version is better. Remember, this is a game of probability because you only have a certain subset of customers or users coming in. You don't have the entire population. So you cannot make the argument very deterministically. It is probabilistically, because you're seeing a sample and then from that you're inferring which version is better with a certain confidence level, obviously. Let's now at this point also talk about why do we care about A/B tests? Why not just look at observational data? Because as we discussed, observational data can be having a lot of different variations. Like there can be a temporal variation, there can be different kinds of external events that might be occurring when the users were coming at this page, right? The environment, the say this business is in a particular industry and that industry might be facing some backlash from the media due to certain environmental concerns, etc., right? So the behavior of the customers at that point of time might differ from the behavior of similar customers at a different point of time due to external things. That's why observational studies are a bit skewed when we want to understand causation, right? When we want to understand when we did this, this occurred, or when we did this for version B, this was the response. We cannot make this argument for certain, because if we are going with observational studies, these are happening across different locations. The users might be across different geographies, the time variation might also be there. So to make this particular causation statement that when we do this we get this, we need to account for all of the other factors which are called nuisance factors to be made constant. We can also do AA tests, right? Where we are just looking at version A. And here we are also keeping version A instead of version B. So we only have one version and we basically want to test our entire experimental design, whether it is working well or not. So what we would expect is when we are keeping one AA test, we will get a certain incoming user base. And for these two splits, right? So we are still splitting for an AA test, right? We only have the same versions in both the places. We would expect the output to be somewhat uniformly distributed if you would conduct multiple AA tests. So sometimes the conversion might be 30%, sometimes it might be 50%, sometimes it might go to 60%, sometimes go down, sometimes go up. So AA tests basically tell us that other than the version, everything else in the experiment on average, it is basically the same, right? So on average you will see that version A, and here also the second result of version A, both of these are giving similar results on average. So basically we are doing the randomization correctly and everything else is working fine. So AA tests are also very useful in practical sense. Let's talk more detailed about design principles of experiments. We talked about randomization, right? So we are trying to randomly include units for the different versions, and that needs to be completely randomized. So it can be that in a split second, we are having 10 different customers which are coming in, and each of them is basically assigned a customer ID by our system. So we can have an odd even split, right? And if we do that for say 1 day or 2 days, we get a lot of different customers in both the segments A and B. And we can be sure that because we did this randomization in this fashion, like odd even customer ID split, that the distribution should be somewhat very similar, because we are doing it very quickly, right? In 1 second we are getting 10 customers, right? So we are doing it very quickly, there's no time difference, and on average we would expect that the distribution is same. There is no reason to expect that the distributions will be different. So this is one example how you can randomly include units, right? And you also, so this is basically talking about this part where we want to include units, but what I just explained was the second part, randomly assigned to conditions. So you're assigning to version A and B, right? Then the second principle talks about replication, which is basically saying how many units should you include in the test, right? Should you have 1,000 users? Should you have 1,000,000 users? Should you have 10 million users? Like where do you draw the line? And what should be the duration of the experiment, right? So when the users are getting split into these two versions, should they be shown, these versions for 1 day, for 10 days? What is the size of the experiment that we want to conduct? This analysis is done by power analysis and sample size calculations, which I will briefly go over very shortly. The third factor or the design principle is blocking, where basically it's a mechanism by which nuisance factors are controlled. So nuisance factors, like I talked about, are external things which might not help us understand the exact causation principle, that because this happened, this was the result. There can be certain nuisance factors which are or interference factors which are, helping us or deterring us from understanding the causation. So it might be that the people who are showing version B, they are in the same geographical location, probably in the same house as those that are shown version A. So there might be some interference, and the feedback loop from that person to the other person who are seeing different versions, that might confound our final answer. So blocking is the mechanism basically by which such nuisance factors are controlled, even interference factors. So design principles are very crucial for designing experiments, and after designing experiments we simply run it, and then we do a hypothesis test to understand which version is better. Let's talk a little bit now about the statistics of it. So we will be looking at experiments with two conditions, that is an A-B test. We can have multiple conditions, right? We can have A, B, C, D, E, F tests. Imagine you had 5 conditions and you are running 15 A-B tests, right? So you are having 15 A-B tests running simultaneously. So on a whole, the amount of variation that you will have is 5 to the power of 15. This is the total number of different variations that you will have, and you can see the number will go around 30 billion. So it is very important to understand and select the conditions, but even so, we will just talk about a simple case, A-B test, which has two conditions. The first condition, we are assigning N1 units, which is N1 users, and the second condition, we are basically assigning N2 units, right? And what we are measuring is the response variable Y, which we are basically using to identify which version is better, and this is the entire process, right? So here we have N1, here we have N2, and we would expect that N1 and N2 are somewhat very close by. Because this is a real life experiment, N1 and N2 can be slightly different. We can compare the means, right? So it depends on the response variable that you want to use, right? It can be something which is talking about a mean conversion rate per hour and so on, right? So there what we do, basically we are comparing means, and what we use is a t-test where we are saying that y1 hat minus y2 hat. Y1 hat is the response that we are seeing from that sample. So it's, for example, this is the response that we are seeing from A, this is the response we are seeing from B. Y1 hat minus Y2 hat is telling us the difference between these two responses, and mu1 minus mu2 is basically telling us the actual difference, what is there unobserved in the actual population, right? So we are saying that basically we want to understand whether there is a significant difference or not, right? And we also want to understand the direction of that difference, which one is better. So this is how the t statistic is defined: y1 hat minus y2 hat minus mu1 minus mu2 divided by sigma hat, because we don't know the variation, right? We don't know the variance. So sigma hat is a function of the sample variance, right? So that's what I have denoted here. And 1 by n1 plus 1 by n2 summed up, and then square root of that. So this follows a t distribution with degrees of freedom n1 plus n2 minus 2, right? So at this point, I've explained how you can compare means and what is the test statistic you need to use, right? Using this, you can also find out the sample size that is good enough for a particular significance level and the power of the test, right? So that is another mathematical detail that I will not go into, but if you want to understand that more in detail, I would definitely recommend to check out power analysis and sample size calculations. You can build up upon this simple representation and understand what is the sample size if you want a certain significance level alpha, say of 5%, and you need also the power of the test. The second approach is comparing proportions. When your response variable is a proportion, it's a similar representation of the t statistic. It's y1 hat minus y2 hat, which is the difference between our calculated responses, minus mu1 minus mu2, right, divided by pi hat multiplied by 1 minus pi hat, multiplied by 1 by n1 plus 1 by n2 whole of square root of the entire thing. And basically pi hat is a function of y1 hat and y2 hat, right? So the proportions that we are actually calculating for the different versions. All right. At this point, we have covered most of the technical details of A/B tests. But there is one important thing that we need to keep in mind when we are designing A/B tests and actually running them in the field. That is the ethics of it. Ethics in data science is very important because we are dealing with sensitive customer data. We are actually understanding their behavior when they are coming to our websites. And some customers, if you're not showing them the proper representation of your business, they might get offended and they might, go out of your funnel. They might just leave your business and, never come back. So this is a simple thing. I mean, there can be more graver consequences of running unethical experiments, right? So let's talk about some of the facets of ethics. There are certain risks always involved in an A/B test. So if we know that the risk is above certain minimal risk factor that we have accounted for our experiment, we need the customer's informed consent that this experiment is going on. Right? Another thing that we need to think about is the benefits. Why are we running this experiment? Is it benefiting us at all? So we need to quantify and understand that very well. The third one is the choice of the customers, which basically relates to the switching costs. They're coming to our business. What happens if they switch to another business, right? Will our experiments prompt them to switch, right? Will it degrade their user experience or not? And the fourth one finally is very crucial, is privacy, data privacy. So we are basically gathering data of customers using this experiment without them knowing it. So this data is customer data, and since it is end user data, it is very, very confidential and sensitive. So we need a system to safeguard the data. And when we are running A/B tests, where the data is getting stored, what are the security measures around it, that needs to be very properly identified. So keeping in mind these ethical principles and understanding the statistics as well as the design principles behind A/B tests, at this point you're ready to basically understand, what your colleague is talking about when he's talking about product analytics and he's talking about, designing certain experiments. So make sure you understand each of these concepts clearly, and feel free to go back and rewind the video and watch certain parts that you missed out on again. So this was session 7 on A/B tests, and the last session that we'll be talking about in the Introduction to Data Science series is optimization, which will be the next one. So make sure you are tuned to that. Please like, share and subscribe the video if you liked it, and let me know if you have any questions or comments in the chat below. Thank you and have a nice day.